All right, guys, so we are on 3.3, day 2. Probably thinking, Miss Garcia, what about 3.2? Like, yeah, we're kind of going out of order. This is the order it needs to go in, so don't worry about it. We got it covered. All right, anyways, example 1. Does the curve have any horizontal tangents? If so, where? Well, first of all, what in the world does it mean to have a horizontal tangent? Well, it means, remember, horizontal lines means the slope is what? 0. That's what it means to have horizontal tangent. That means that the tangent line have a 0 slope. Okay? Okay, so that's what we're looking for. So we have a series of steps that we're going to need to follow. And we're not doing all of these. I don't want it to be too long, so I'm going to do this one, but I'm not going to do B. Okay, so first of all, we need to find the derivative. So the derivative of this function, let me zoom in. Okay, so drop the 4 in the front, that would be y prime equals 4x to the third minus, drop down the 2 in front, so minus 4x, and then the 2 is a constant, so it doesn't even matter. I don't know why I wrote it all the way over to the left, but oh well. Okay, next, because we're trying to find where the slope is 0, we have to set it equal to 0. Okay, so we'll have 0 equals 4x cubed minus 4x. Then from there, we need to factor. So we'll have, let's see, 0 equals, if we factor out, they have a common factor of 4x, so we'll have x squared minus 1. And then we can break those factors apart and set them each, equal to 0. So we'll have, so remember you set it equal to 0. You break them apart, set them equal to 0. So we'll have 4x equals 0 and x squared minus 1 equals 0. So for the first one, we'll get x equals 0. For the second one, if you add 1 to both sides, you get x squared equals 1, and then take the square root on both sides, you're going to get x equals plus or minus 1. Okay, so we got our 3 solutions, which makes sense because we had it to the 3rd degree. Remember, we learned that back in Math 3? Okay. All right, after that, we need to get the x values. Get the y values. We have the x values. Get the y values. Okay, and we know that we're going to have 3 that we need to find because we have 3 x values. So we know that we have an x value of 0. We need to find the y value that goes with that. We have an x value of positive 1. We need to find the y value that goes with that. And we have an x value of negative 1. And we need to find the y value that goes with that. So we need to find those 3 points because we had to say where does the curve have horizontal tangents? And this one happens to have 3. Okay, so let's find those 3 y values. So let's take this up here. So there's a couple different ways that we could do this. I showed you at the end of the last notes that you could use synthetic division, or we could just plug it in. So let's try plugging it in this time because it's pretty easy. It only has 3 terms here. So let's try y equals, let's plug in a 0 for the x, so 0 to the 4th minus 2 times 0 squared plus 2. Well, 0 is 0, and then all we have left is a 2. So when the x value is 0, the y value is 2. Okay? Next, let's try plugging in the 1. So we'll have 1 to the 4th minus 2 times 1 squared plus 2. Well, 1 to the 4th is 1 minus 2 times 1 squared, so minus 2. 1 minus 2 is negative 1. Negative 1 plus 2 is a positive 1. So when the x value is a 1, the y value will be a 1. Now let's try the negative 1. Negative 1 to the 4th minus 2 times negative 1 squared plus 2. Negative 1 to the 4th is 1. Negative 1 to the 2nd is 1. So 1 minus 2 is negative 1. Negative 1 plus 2 is 1 again. Okay. So we have our 3 points. So I'm going to box those. That is the answer. You know what? I'm going to go ahead and do B because it's really short. I'm just going to do it. Okay. So we're doing the same thing. So step 1 was to find the derivative. So f prime of x equals, the derivative of this will be, let's see, 2x minus 4. Okay. Got the derivative. Now we need to set it equal to 0. So 2x minus 4 equals 0 because we're trying to find where the horizontal tangents are. Horizontal lines have 0 slopes. Add 4 to both sides. 2x equals 4. Divide by 2. X equals 2. So this one's only going to have one point where there's a horizontal tangent. So we only have one x value that we got here. Okay, so plug it back in to find the y value. Or you could use synthetic division. This one's pretty easy to plug in. So 2 to the 2nd power minus 4 times 2 plus 5. So that would be 4 minus 8 plus 5. So negative 4 plus 5 equals 1. So that is the point 2, 1. Nice. So notice once you get the hang of the steps, you don't have to write it all out like that. It gets quicker. It's just, that's for you as you're learning how to do it. All right, example 2 says use the calculator to find any horizontal tangents for y equals 0.2 x to the 4th minus 0.7 x to the 3rd minus 2x squared plus 5x plus 4. Whew, that's a long line. Okay, so I'm going to pull out my calculator and we're going to do this, okay? So, and I'm going to give you guys some notes to write down for your notes. The best way to do this in the calculator, because there are multiple ways. If you were to look this up like on YouTube or something, the best way is to do this. Put the derivative into y equals. So you know how when you go to graph, you hit y equals and then you put in your function? Well, instead of putting this, put the derivative, because you're trying to find horizontal tangents. Put the derivative into it and graph it, comma. Then you're going to see where it hits the x-axis. Because wherever it hits the x-axis, that means that the slope was 0. Because at x, the y value is 0. Okay, and that's what we want. We want the slope to be 0 because that's what it means to have a horizontal tangent. Okay. All right, so let's try this. I'm going to use my graphing calculator. But I'm first going to set my window back to normal. Okay. Oops, 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 oops. Oops, sorry. Clear, clear, clear. I freaked out my calculator. It's thinking. Hold on a sec, guys. Come on, calculator. I think it's because my battery's low and I didn't realize I didn't have a charging cable for it, so I had to order one on Amazon and now it's mad at me. Okay, there we go. Y equals. I was obviously plotting some other things in here. Okay. All right, so what would the derivative be? Okay, so let's figure out what that derivative would be first before I actually pull out my calculator. So remember, we have to bring down the 4. 4 times 0.2 is what, 0.8? 4 times 0.2 is 0.8, so y prime equals 0.8 x to the 3rd minus 0.7 times 3 is 2.1 x squared minus, bring down the 2, that would be a minus 4x, and then plus 5, and the constant doesn't even matter. So then this is what I'm going to type into that calculator. Okay, so now I'm good to go, for real this time. So 0.8 x cubed minus 2.1 x squared minus 4x plus 5. Okay, and then I'm going to hit graph. That was fun. Okay, so I see that it is crossing the x-axis 3 times, right here, and right here. So what we got to do, let me zoom in for you guys. What you got to do is move the cursor so that you can see where the x is. So see how I hit the right arrow on my arrow buttons right here? And so I want to go back over here and see, okay, oops, went past it. So this looks like it's negative 1.81 or 82. Yeah, that looks on it. So negative 1.82, if I round it. Okay, so there's that. So there's 1 point. We're going to need to find the y value. Now let's try the next one. So I'm going to move my cursor over. Looks like about right there at 0.985. I got to find the y value that goes with that. And then the last one, scooch that point on over. Looks like 3.56. Okay, and now all we have to do is find the y values. So to find the y values, you have to plug it back into the original equation. So this is going to be our answer once we find the y values, but I want you guys to write yourself a note that the y values come from the original equation, okay? The original EQ. So when we plug these back in, we're plugging them back into this, the original equation, okay? So I'm not going to go through all those steps because you're literally just plugging it in. What's nice is if you're using this to do it, you can literally type it all in one line and then hit equals and it does it for you if you do it correctly. I recommend using parentheses when you're ever not sure. So you're going to end up getting a y value of negative 5.305. I recommend you guys plugging this in and making sure that you get the same as me. And then the next one is 6.503. And then the last one is negative 3.006. Okay. So that's using our graphing calculator to help us out a little bit. All right, example 3, it says find the equation of the tangent line to the curve given at the indicated point. Find the normal line at the indicated point. Use your graphing calculator to verify your results. Okay, so this one we're mostly using our hands to get the answer. We are finding the equation of the tangent line. We are finding the equation of the normal line. And then we're going to use our graphing calculator to verify what we get. So first off, we need to find the slope of this equation so that we can find the tangent line. So I need y prime, and that would be, you should be getting the hang of this by now, 5x to the 4th minus, bring down the 3, so 6x squared plus 7. And now I need to find what the slope is at that x value of a 1. So that means I got to plug in a 1. So y prime of 1 will be 5 times 1 to the 4th minus 6 times 1 squared plus 7. 1 to the 4th is 1. 5 times 1 is 5 minus, that'll be a 6 plus 7. So that'll be a negative 1 plus 7 which is a 6. So that is the slope. So now we can write the tangent line, t of x equals 6 times x. The x value was a 1, so at that point, and then the y value is a 6, so plus 6. Simplify this out, distributive property, we'll have 6x minus 6 plus 6. The 6's cancel, so it's just 6x. So the tangent line is 6x. So let's put underneath, this is the tangent line. Okay, let's find the normal line, n of x, which is much easier now because we just have to take the slope of the tangent line and find its opposite reciprocal. The opposite reciprocal of 6 is negative 1/6 times the same stuff, x minus 1 plus 6. Distributive property, we'll get negative 1/6 x plus 1/6 plus, let's go ahead and get a common denominator. It needs to be a 6. I have to multiply top and bottom by 6. So that would be 36 over 6. So n of x is going to equal negative 1/6 x plus 37 over 6. And there is our normal line. Okay. So we've got the tangent line, we got the normal line, and now we have to do the verifying part. So, this part. This is how you need to do it. You need to put all 3 equations into the graphing calculator, into the GC. So here are your 3 equations. You're going to have y1 equals the original, x to the 5th minus 2x cubed plus 7x. You're going to have y2 is 6x. And you're going to have y3 is negative 1/6 x plus 37/6. Okay, so we're going to put all those 3 points in there. Okay, so where's my graphing calculator? Let me clear what I had in there already. So I'm going to have, make sure you guys can see, x to the 5th minus 2x to the 3rd plus 7x, and that's the first one. 6x is the second one. And then because that's a fraction, I'm going to put that fraction in parentheses, negative 1/6, and then x plus, no, just in case, 37 over 6 in parentheses. And then I'm going to hit graph. And it's thinking, I see it's thinking up here. There's the original. There's the tangent line. There comes my normal line, hitting it at a 90-degree angle. Okay, so I can barely see that, so I want to change my window a little bit. I know that the point that that's crossing at is the point 1/6, because that's what it gave me here. So I just want to kind of zoom in that part. So I'm going to go to window, and I want my x minimum to be 0. And I want my x maximum to be, let's try maybe a 2 or a 3. Just see what happens. And then let's have the y minimum be 0. And the y max, since it's hitting the point 1/6, so the y value high is a 6. Let's go up to like, yeah, a 10. Let's see how that looks. And we'll graph and see what it looks like. So there's this portion of the original graph, the tangent, and the normal curve, or the normal line. Okay. So for this one, it doesn't look exactly, but when it was zoomed out, it looked a lot better. So as we're zooming in, there's going to be a little bit of a margin of error there. All right. There we go. Quit. All right. Turn the page. Letter B. We're going to skip this one, actually, because Okay. Product rule. So we have the power rule, and now we have the product rule. You guys are going to like this one too. So if f and g are two differentiable functions, then d dx of f of x times g of x, the derivative of f of x times g of x, is the f of x times the derivative of g plus g of x times the derivative of f. Okay, so the first times the derivative of the second plus the second times the derivative of the first. There's your tongue tie or tongue twister of the day, but that's how we say it. Okay, so let's try it out. We're gonna find f prime of x, so the derivative of f of x, and it is x squared plus 1 times x cubed plus 3. So there's technically two functions in one here. So we'll let this one be the first one, and we'll let this one be the second one, because they're being multiplied together. We're gonna use the product rule on it. Okay. So let's find the derivative and let's use that product rule. So we'll have, making sure you guys can see. So f prime of x equals the original function, so x squared plus 1, times the derivative of the second. So the derivative of x cubed plus 3 is just a 3x squared, because remember the constant doesn't matter. Derivative of a constant is 0. Plus, now I need the second, which is x cubed plus 3, times the derivative of the first. The derivative of the first would be a 2x. Okay, now we just have to multiply that out. Really easy. So f prime of x equals, let's see, 3x squared times x squared is a 3x to the 4th. 3x squared times 1 is a 3x squared. Plus 2x times x cubed is a 2x to the 4th. 2x times 3 is a 6x. And then we just have to put it in order, because standard form and combining like terms. So f prime of x is going to equal 3x to the 4th, and 2x to the 4th is 5x to the 4th. And then those were the only like terms, so plus 3x squared plus 6x. And that's the derivative. Isn't that nice? That was so easy. And we didn't have to multiply that out, which you could, and then use power rule. But if it's like this, we can skip those steps and make it a little bit quicker by using the product rule. I like it. All right, example 5, it says to find the derivative of h of x equals 3x minus 2x squared times 5 plus 4x. Verify your results by multiplying the two binomials and using the power rule. So we're going to use it. We're going to do the product rule on it, and then we're going to verify that we're going to get the same thing by doing the power rule, the one that we learned in the last lesson. All right, so I like color coding things. So this is my first, and this is my second. Okay, so let's use the product rule first. The new rule. Okay. So let's try it. So we'll have h prime of x equals the first, which is 3x minus 2x squared, times the derivative of the second. So the derivative of the second, well, that's a constant, so it doesn't matter, so it's just a 4, plus the second, which is 5 plus 4x, times the derivative of the first. The derivative of the first would be a 3 and then a minus 4x. Okay. We need to multiply these things out. So we'll have h prime of x equals 12x minus 8x squared plus, now this one, 5 times 3 is 15. 5 times negative 4x is a negative 20x. 4x times 3 is a 12x. 4x times negative 4x is a negative 16x squared. Okay, and let's combine like terms. So we'll have h prime of x equals, let's see, the highest degree is the squareds. So I have a negative 8x squared and a negative 16x squared. That would be a negative 24x squared. And then we have the x's. We have a 12x, a negative 20x, and a positive 12x. So let's add the positive ones together first. 12 and 12 is 24. So 24x minus 20x is a positive 4x. And then we just have the constant of a plus 15. Okay, there's the derivative using the product rule. Okay, let's see what it looks like when we use the power rule. So to use the power rule, we're going to need to multiply that out first. So we're going to be multiplying and then using the power rule. Okay, so let's first multiply. So I have h of x equals 3x minus 2x squared times 5 plus 4x, and let's multiply it out. So we'll have h of x equals 3x times 5 is a 15x. 3x times 4x is a positive 12x squared. Negative 2x squared times 5 is a negative 10x squared. Negative 2x squared times 4x is a negative 8x cubed. Okay. Let's go ahead and combine like terms. So we'll have h of x equals, the highest degree is that negative 8x cubed. And then the squareds, we have a 12x squared and a negative 10x squared, so that'll be a positive 2x squared. And then we have a positive 15x. Okay, now, remember, we haven't even taken a derivative yet. So now let's do the power rule. So h prime of x, the derivative of h of x is going to be, let's bring down the 3, that would negative 8 times 3 is negative 24, x squared. Bring down the 2, that would be a positive 4x, and then plus 15. And now compare. Are they the same? Heck yeah. So literally, the power rule took like a couple steps longer. So for this problem, it really didn't matter which one you use. I would probably still use the product rule because it's just quicker. But if you don't think about using that, you can use the power rule and it's going to work all the same. So how about that? That'll be nice, huh? Having options, always a good thing. All right, true or false? Let's see, number 1. If f prime of x, the derivative of f of x, equals the derivative of g of x, then f of x equals g of x. I wonder. Well, the answer is going to be false. The reason is, just because their derivatives are equal doesn't mean necessarily that they're going to be equal. Want to know why? They could have different constants. Constants could be different. Whenever you say that something is false, you always have to come up with a counterexample that shows why you're saying it's false. So here's my counterexample. Say f of x equals 3x squared plus 4. The derivative of that would just be a 6x. And let's say g of x is 3x squared minus 24. Well, the derivative of g of x is also 6x, but these are not the same function. So there's my counterexample. Okay. Number 2, if f of x equals g of x plus a constant, then the derivative of f equals the derivative of g. Is this one true or false? It is actually true. Want to know why? Constants don't matter. The derivative of a constant is 0, so it's not going to affect anything. So our reasoning is constants won't matter. And that is because its slope will always be 0. All right, next page. All right, if y equals pi squared, then dy dx, the derivative, is going to equal 2 pi. What do you think? Is it? Nope, it's false. Want to know why? Pi is not a variable. Pi is a constant. Pi isn't a variable. It's a constant. We know what pi is. Pi is not an unknown. Pi is 3.14159 and its decimal place goes to infinity. It's an irrational number, but it's a number. It's a constant. Pi is always that number. So we can't treat it like it is an x. We treat it like it's a constant because it is. All right, number 4. If y equals x over pi, then dy dx is going to equal 1 over pi. So the derivative will be 1 over pi if the original is x over pi. Well, the answer is true. And let's show you why. So the original is y equals, let's write it x to the first over pi. So when we take the derivative using the power rule, we would have y prime equals, you bring down the 1, so it would be 1 x to the 1 minus 1 is 0 all over pi. Anything to the 0 power is just 1, so it's just 1 over pi. So yeah, it checks out. Check. Application problems. All right. Word problems. Woohoo! Some of these might look familiar because these are similar to things that you might have seen in physics. Okay. So it says use a position function s of t equals a negative 16t squared plus v naught t plus s naught, where v naught is the initial velocity. V naught is the initial velocity, and s naught is the initial height of the object. Okay. So if v naught is the initial velocity, the initial speed, then initially when we're starting off from, sitting still, that means the initial velocity is 0. Okay. Especially because we're dropping a silver dollar from the top of the Empire State Building. So before it's dropped, it's not moving. So its initial velocity is 0. Okay. So a silver dollar is dropped from the top of the Empire State Building, which is 1,362 feet tall. Okay. So this tells me S naught, the initial height, because that's how tall we're dropping the silver dollar from. Okay. That doesn't say so, it says S naught, the S sub 0. Okay. So number 1, it says determine the position and velocity, which is instantaneous rate of change, functions. So we're determining 2 functions, position and velocity. Okay. So the position is going to come from this. We just have to plug in what we know. So we'll answer number 1 down here. So we're going to have S of t equals negative 16t squared plus, well, if the initial velocity, because we're starting from a standing still position, the silver dollar hasn't dropped yet, it hasn't moved, so its initial velocity is 0. That means that gets wiped out, it's just 0. But the initial height that we're dropping it from is 1,362 feet. Okay, so here is our position function. So I'm going to label it. And now we need the velocity, which is the same as the instantaneous rate of change. Well, instantaneous rate of change is the derivative. So we're going to take the derivative of S of t, And this is going to produce us with a velocity function. So we'll call it v for velocity, so v of t. And let's take the derivative of this function. So we have to drop down the 2. Negative 16 times 2 is negative 32. T, 1362 is a constant, so it goes away. And there is our velocity function. Okay. All right, number 2 says determine the average velocity. So average rate of change on the interval 1 to 2. Okay, well, we need to find the coordinates at this interval. So we know that we have an x value of 1 that we need to plug in and an x value of 2 that we need to plug in. And you always plug it into the original. So negative 16 times 1 squared is just negative 16. Have that in my calculator. And then plus 1362 is 1346. Okay, and then plug into 2. So we know that 2 squared is 4, so negative 16 times 4 plus 1362 is 1298. Okay, so we need to find the average rate of change. We have to use the slope formula, delta y over delta x. So the change in y, y2 minus y1 would be 1298 minus 1346, all over x2 minus x1, so 2 minus 1. So 1298 minus 1346 is negative 48. Over 2 minus 1 is 1, so it's just negative 48. And this is dropping in feet per second. So the average rate of change, it is falling, that's what the negative means, falling at a rate of 48 feet per second. That's pretty fast. That's its average rate of average velocity. Okay, now let's take a look at the next one, number 3. Says to find the instantaneous velocities when t equals 1 and t equals 2. Okay, so we're finding instantaneous velocities, so we're using the v of t function. So v of 1 is what we're looking for, and v of 2. So we're using this function. So we have negative 32 times 1, which is negative 32. So negative 32 feet per second is how fast it's falling at 1 second. And then negative 32 times 2 is negative 64 feet per second when it's falling at 2 seconds. So the speed is increasing quite a bit. Okay, but that's gravity. Gravity is pulling it and pulling it and pulling it. All right, number 4. It says find the time required for the coin to reach the ground. So when we reach the ground, that means the height is 0. We've reached the ground. So that means we can set our function, s of t, equal to 0, our position function. So 0 equals negative 16 t squared plus 1362. And we're going to solve this. So I'm going to subtract 1362 from both sides. So we'll have negative 1362